At 8:08 hours local time on November 29, 2023, a violent explosion occurred deep inside Russian territory, shaking the entire Severomuysky area. Flames from the explosion could be seen from the opposite side of the mountain about 13 miles away, while a column of thick black smoke rose more than 270 feet into the air. A Russian freight train consisting of 41 cars carrying fuel, weapons, and artillery ammunition was engulfed in flames. What made this attack different from everything previously witnessed was the extreme distance. The train was located deep inside Russian territory, approximately 3,100 miles from the Ukrainian border. This supply route was protected by multiple layers of security and dense modern defensive systems that the Kremlin had once declared impenetrable. Yet, 8 Ukrainian UAV pilots proved that nowhere inside Russian territory could be considered completely safe, using drones that cost less than a standard smartphone. 30 miles away, operators from the Security Service of Ukraine, the SBU, monitored degraded video signals through control link transmitters operating at extreme range. 8 FPV drones were crossing distances and terrain that Russian military experts believed made such a mission impossible. A standard FPV usually has an operational range of only about 5 miles, but these UAVs had flown more than 12 miles and were still continuing forward. Behind the formation, Ukraine's main Directorate of Intelligence, the HUR, continuously provided real-time intelligence. Simultaneously, Ukrainian electronic warfare units monitored and intercepted Russian communications, while a team carrying anti-jamming equipment remained on standby to penetrate electromagnetic interference if required. Suddenly, the images on the control screen began stuttering violently, covered with bands of interference before cutting out completely. The link between the attack UAVs and the control crew had been severed. The first relay UAV, the critical link maintaining communications for the mission at a distance of 35 km, had just been destroyed. A Russian 9K-38 Igla-S manpads had locked onto and struck the UAV while it was hovering at an altitude of 1,400 feet. Without the relay station, the control signal could not pass through the terrain and the jamming zone ahead. The transmitted images flickered, navigation commands arrived late, and then failed to reach the attack UAVs at all. Without the link, the entire formation was at risk of losing contact with its operators, threatening to collapse the mission within seconds. This represents the primary challenge of extreme-range UAV operations, maintaining precise control when the signal must cross nearly 30 miles of mountains, dense forests, and electronic jamming zones. Ukraine utilizes a control link system operating across the 2.4 to 5.8 GHz frequency range to create an almost instantaneous connection. Digital signals can travel far, but a delay of about 200 milliseconds is dangerous. When a UAV is racing toward a train moving through a tunnel entrance, that delay can cause the impact point to miss by as much as 20 feet. Determining whether the FPV strikes its designated target in dense forests and mountainous terrain. A stable signal usually travels only about 3 miles. Therefore, the SBU deployed a chain of 10 relay UAVs spaced 3 miles apart, creating a communication corridor extending from the control station to the Severomuysky-Tunnel. Primary UAVs flew at high altitude to optimize transmission, while backup UAVs flew lower, concealed by terrain to avoid Russian radar and surface-to-air missiles. They were positioned far apart so a single interception would not destroy multiple links simultaneously. With the primary relay UAV shot down, the SBU members inside the control station watched screens filled with static. At the 6th second, the backup relay UAV was activated. Flying at an altitude of about 500 feet, it was harder for Russian air defenses to detect, though positioned 1.5 miles away from the optimal transmission point. Signal strength recovered to 50%. Despite torn video and jumping altitude data, SBU pilots regained control of the 8 FPV UAVs racing toward the Russian train. This mission required coordination among multiple Ukrainian units over several weeks. The SBU controlled the 8 UAVs and maintained the 30-mile relay chain. Near the entrance of the Severomuysky-Tunnel, a partisan group supported by the UR secretly placed an explosive charge containing 180 pounds of explosives beside the railway track. The charge was timed to detonate the exact moment the locomotive emerged from the tunnel, while most of the 41-car train remained trapped inside. Meanwhile, the Alpha unit monitored Russian communications for signs that the ambush had been exposed, while Ukrainian electronic warfare teams monitored interference sources, ready to intervene. SBU pilots had trained for hundreds of hours under conditions of distorted or lost video, using railway tracks, rivers, and power lines as manual navigation references ahead. The 41-car Russian train was advancing toward the Severomuysky-Tunnel as the 8 FPV UAVs approached from multiple directions, with the lead UAV 18 miles from the target. When the lead FPV was still 15 miles from the target, the image on the control screen suddenly broke into blocks. The video flickered, control commands responded slowly, and the UAV icon began drifting away from the flight corridor. The signal delay increased from 50 milliseconds to more than 300 milliseconds. The FPV had just entered the operational zone of the Borisoglepsk-Zoo, an electronic warfare network that Russia had deployed in advance. A Russian reconnaissance station detected the control link signal and transmitted the data to the command post. Within seconds, multiple jamming stations simultaneously joined the attack. One station targeted the video signal on the 5.8 GHz band, another suppressed the 2.4 GHz control channel, while a third source distorted the positioning data on the SBU screens. Everything nearly collapsed at the same time. The image disappeared, direction became inaccurate, and every command arrived late. The control crew immediately reduced the volume of transmitted data. Instead of attempting to maintain high-quality video, the system sent back only isolated frames along with minimum parameters such as altitude, speed, and flight direction. The video transmission rate dropped from about 30 frames per second to only 1 frame every 2 or 3 seconds. The FPV continued advancing using inertia, its pre-programmed route, and reference points stored in its memory. From that moment on, the pilots could no longer control the drones entirely by sight. They had to estimate each UAV's position between signal windows that lasted only a few seconds. The Borisoglepsk-2 was extremely powerful, but it could not concentrate maximum power on every channel simultaneously. Each time one station switched to a new frequency, an extremely brief opening appeared in another part of the network. Ukraine did not need to break through the entire wall of interference. They only needed openings long enough to check the UAV's altitude, direction, and relative position. One frame appeared, then disappeared. 2 seconds of clear data came through before the screen once again sank into interference. Within the formation of 8, 4 lead FPVs flew widely spaced in front. The leading UAV served as a probe, forcing the Borisoglepsk-2 to continuously change its antenna direction and suppression mode. Each time it found a temporary signal corridor, the data was immediately passed to the crews behind it. 30 seconds later. The second FPV entered that exact corridor before Russian operators could completely reconfigure the jamming system. The next 2 UAVs changed their altitude from 500 feet to 300 feet and altered their approach direction to avoid being identified as a single cluster of electronic targets. The remaining 4 UAVs continued approaching along different axes, but the Borisoglepsk-2 had not yet used its most dangerous measure. The system began spoofing navigation signals on the Ukrainian map, causing the UAV icon to suddenly shift several kilometers away from its actual flight path, if the pilots had trusted those coordinates. The FPV would have left the railway line and flown directly into the mountainside. However, they no longer depended entirely on satellite signals. The control crew compared flight time, speed, wind direction, and the terrain features appearing in the brief video frames. A road appeared for less than 1 second, followed by a strip of forest, and finally the corner of an industrial area at the edge of the screen. 3 reference points confirmed that the FPV was still inside the correct corridor. The coordinates on the map were false, but the UAV had not been pulled away from its flight path. As the formation entered the densest part of the jamming zone, the Ukrainian electronic warfare team activated its final option. A high-powered directional transmission penetrated the suppression layer and opened a brief electronic window. The image from the lead UAV reappeared, blurred, shaking violently, and almost completely without color, but clear enough to recognize that the railway tracks were still leading toward the Severomuysky-Tunnel. In return, the Ukrainian transmitter immediately lit up on Russian electronic reconnaissance equipment like a lighthouse in the darkness. The operator placed his hand on the switch and counted every second. 10 seconds, 20 seconds. The Borisogledsk-2 stations began rotating their antennas and narrowing the search area. At the 25th second, Ukraine cut the transmission. The equipment was packed away and the vehicles immediately left the position before Russia could complete the coordinate fix. The UAVs switched back to autonomous mode. GPS continued jumping erratically and the video still flickered, but the lead UAV had correctly re-established the approach corridor. The 3 lead UAVs followed its data. The remaining 4 advanced from different directions using the railway tracks and terrain as navigation references. After flying nearly 8 miles through the Borisogledsk-2 suppression zone, one final image returned to the SBU screen. It was blurred and constantly flickering, but in the center of the frame, the railway tracks led directly toward the Severomuysky-Tunnel. All 8 FPVs were still in the air. Through the dense interference, the SBU pilots finally saw the 2 railway tracks leading into the tunnel blurred beneath them. The 8 FPVs immediately descended to an altitude of 170 feet and followed the railway line. The GPS was still jumping erratically, but that no longer mattered. As long as the cameras could see the 2 steel rails, no false coordinates could pull them away from the approach corridor. The control crew switched completely to manual mode, navigating through low-quality frames that appeared and disappeared after a few seconds. The Russians immediately activated the Pole 21. Distributed jamming stations along the railway corridor simultaneously increased their power, suppressing GPS, GLONASS, Galileo, and Baidu signals throughout the entire area. The positioning data disappeared completely. But the 8 FPVs did not turn back. They continued following the railway tracks through their cameras. The Pole 21 had disabled satellite navigation, but forced the UAVs to switch to a method it could not jam, optical navigation based on what the cameras could visually confirm, when the formation was only 6 miles from the train. A Panzer S1 radar detected the lead FPV. The target was locked. The fire control computer determined its speed, altitude, and interception point. The launcher began turning toward the railway line. Only 8 seconds remained before the first missile would leave the launch tube. Ukraine had prepared for this exact moment when the Panzer S1 targeted the formation. Suddenly, 6 new targets appeared on the Russian radar. These were $500 decoy UAVs fitted with corner reflectors that made them appear much larger and more dangerous on radar than their actual size. Within seconds, a single target became an entire formation racing toward the train. The Panzer's computer could not distinguish between the cheap decoys and the warhead-carrying attack FPVs. The Russian crew was forced to choose: fire at every target and risk running out of missiles, or delay to classify them and accept the possibility that the real UAVs would break through. They decided to fire. The missiles left the launchers one after another, racing toward the largest radar signatures. The decoy system did not work perfectly, as cold weather weakened batteries and affected handmade electronic circuits. Nevertheless, the Panzer launched 8 of its 12 missiles at devices built from racing drone components, cheap materials, and energy drink cans. Within seconds, 2/3 of the system's missile stock had been expended on false targets with a total value lower than a single laptop computer. The Pole 21 had caused the UAVs to lose GPS, and the Pantsir had detected the formation and opened fire. But the 4 lead FPVs remained intact and continued following the railway tracks. The other 4 closed in from behind and from different directions. Russia's modern defensive layers had not stopped the attack. They had only helped Ukraine identify the Pantsir's position and forced the system to expend nearly all its missiles before the real targets appeared ahead. The 41-car train was preparing to enter the Severomuysky-Tunnel, and the 8 FPVs were now only a few minutes of flight from the 180-pound explosive charge. The Pantsir S-1s had only 4 missiles remaining, but retained defensive capability through its 2 30mm Zu-38M automatic cannons, which feature a combined rate of fire of nearly 5,000 rounds per minute. At a distance of less than 2 miles, they could turn the entire railway line into a wall of fire. The 8 FPVs immediately descended to an altitude of about 30 feet, skimming the tops of the grass. The Pantsir crew turned the turret toward the railway tracks and poured fire across the approach corridor, with 30mm rounds tearing through the air and sending columns of dust erupting directly in front of the formation. The 2 lead FPVs immediately broke away from the formation to draw fire. One climbed away from the tracks and flew directly toward the Pantsir radar, while the other circled toward the right flank and approached from behind the turret. The Russian crew was forced to shift its fire. The first UAV was destroyed less than 1,000 feet from the Pantsir, but the second continued diving toward it, drawing away firepower from the main flight path for several critical seconds. The remaining 6 FPVs descended lower and passed through the blocked area. 2 UAVs had been sacrificed, but the approach corridor was opened. At 07:56 hours local time, the locomotive of the 41-car train began entering the Severomuysky-Tunnel. The 6 FPVs were now 4 kilometers from the ambush area, holding their positions behind the mountainside to wait until the locomotive appeared at the tunnel exit, while most of the fuel, weapons, and ammunition cars remained trapped inside. At 8:10 hours local time, the Alpha unit intercepted a brief message from Russian railway security forces indicating the locomotive was leaving the tunnel. SBU pilots accelerated the 6 FPVs simultaneously, following the railway tracks toward the 180-pound explosive charge. Through the distorted video signal, SBU pilots saw black smoke rising above the forest as the train accelerated out of the tunnel. The remaining FPVs were 2 miles from the target, racing along the mountainside at nearly 80 miles per hour. As the locomotive entered the tunnel exit, Russia's final defensive layer was activated. An A33L system installed on the train increased transmission power, creating an electronic suppression zone designed to jam GPS, GLONASS, and satellite links within a 20-meter range. Positioning data disappeared, and the electronic compass gave false readings. But the weak control link signal continued transmitting through the chain of relay UAVs. Pilots switched entirely to manual control, navigating visually along the steel rails toward the tunnel exit. The original plan called for 1 FPV to strike the detonating device beside the tracks as the locomotive emerged. However, maximum power from the A33L caused the control link signal to deteriorate further, freezing the video and making a precision strike on the small detonating device nearly impossible. SBU operators altered the tactic. The lead FPV would attack the first fuel car directly, using the secondary explosion of thousands of liters of fuel to trigger the explosive charge near the tunnel entrance, traveling at nearly 40 miles per hour. The targeted fuel car remained inside the impact corridor for only 6 seconds. At a distance of less than 1,500 feet, the image disappeared completely, forcing the operator to rely on calculated timing and manual reflexes. At 08:17 hours local time, the first FPV crashed directly into the lead fuel car. The anti-tank warhead pierced the steel plating, igniting 40,000 liters of diesel fuel. A fireball erupted at the tunnel entrance, reaching temperatures over 9,800 Fahrenheit and sending flames 200 feet high. The emergency braking system locked the wheels, bringing the train to a halt with half of its cars trapped inside the tunnel. Seconds later, the second FPV struck the fuel car directly behind the first impact point. The secondary explosion ripped steel plates from the frame, spilling burning fuel onto the railway bed directly toward the 180-pound explosive charge. Die letzten 3 FPV-Drohnen befanden sich noch in der Luft. Der Tunneleingang war eingestürzt und die vorderen Kesselwagen brannten, aber einige Munitionswagen nahe der Spitze des Zuges waren noch intakt und hätten von den russischen Kräften abgekoppelt werden können. Die erste FPV kreiste um den Hang, sank unter 40 Fuß und näherte sich aus Richtung der Lokomotive. Durch eine Lücke im Rauch erfasste die Kamera die Umrisse des ersten Güterwagens. Der Pilot drehte die Drohne nach rechts und traf exakt die Kupplung zwischen der Lokomotive und dem Munitionswagen. Die Explosion zerriss die Kupplung und die Bremsleitungen, wodurch die Lokomotive vom brennenden Zugteil nicht mehr getrennt werden konnte. Janis Ischo 3. Die nächste FPV näherte sich aus der entgegengesetzten Richtung und schlug direkt in der Mitte des Wagens ein. Kleine Explosionen ertönten, als die Munitionsbehälter im Inneren zu detonieren begannen. Schließlich wurde der gesamte Güterwagen zerrissen und schleuderte rotglühende Stahlfragmente entlang der Bahnstrecke. Die letzte FPV durchdrang den Rauch und traf das Fahrgestell unter dem Munitionswagen. Die Detonation entgleiste den Wagen, kippte ihn auf die Seite und warf ihn in das brennende Treibstoffmeer. RBK Ukrainischer 1. Die Flammen breiteten sich vom Tunneleingang bis zur Zugspitze aus. Die Lokomotive war zerstört, die Bahnstrecke verschüttet und die Wagen im Inneren des Berges brannten im eng eingeschlossenen Raum weiter. Alle 8 FPVs waren verloren, aber der aus 41 Wagen bestehende Zug besaß keinen Ausweg mehr. Als die schwarze Rauchsäule über dem Severomuysky-Gebirge aufstieg, erkannten die russischen Streitkräfte, dass diese Explosion nicht nur einen einzelnen Zug zerstört hatte, sondern eine der wichtigsten Nachschubrouten in Ostsibirien blockierte. The New Voice of Ukraine. NVDer Severomuysky-Tunnel ist Teil eines vitalen Eisenbahnkorridors, der Westrussland mit dem fernen Osten, China und Nordkorea verbindet. Waffen, Munition, militärische Komponenten und Güter aus Asien müssen solche Transportrouten passieren, bevor sie an die ukrainische Front verlegt werden können. Eine einzige Explosion zwang nachfolgende Züge zum Anhalten, zur Umleitung oder zum Warten auf die Reparatur der Strecke. Jede Stunde der Unterbrechung bedeutete, dass Treibstoff die Fronttruppen nicht erreichte, Artilleriemunition nicht in den Depotlagern ankam und militärisches Gerät seinen Weg nach Westen nicht fortsetzen konnte. Kiew-Postis ist zudem eine Schlüsselroute für den russischen Handel mit Asien. Mit der Blockade des Tunneleingangs bemaß sich der Schaden nicht nur an der Zahl der zerstörten Waggons, sondern an tausenden Tonnen Fracht, die im gesamten Netzwerk aufgehalten wurden. Die wichtigste Botschaft lag jedoch in der Distanz. Die Operation wurde fast 6.000 Kilometer von der Ukraine entfernt, tief im Inneren Sibiriens durchgeführt, einer Region, die Moskau einst außerhalb der Reichweite des Gegners glaubte. Woenne Delobscho 1. Für die Durchführung benötigte die Ukraine ein Aufklärungsnetzwerk innerhalb russischen Territoriums, Spezialkräfte an der Bahnstrecke und Drohnenpiloten, die in der Lage waren, 8 FPVs über fast 30 Meilen Berg- und Waldgelände durch mehrere Schichten von Luftverteidigung und elektronischer Kampfführung zu steuern. Millionenschwere Verteidigungssysteme konnten die kostengünstigen UAVs nicht daran hindern, den Zug im präzise berechneten Moment zu erreichen. Kiew-Post, der Angriff, zerstörte nicht nur Treibstoff, Munition und Infrastruktur, sondern legte eine Schwachstelle im russischen Sicherheitsarchitektur offen. Selbst eine der strategisch tiefst gelegenen Transportrouten des Landes konnte nicht mehr als vollkommen sicher gelten. Für die Ukraine bedeutete die Operation einen psychologischen Erfolg. Sie bewies, dass Entfernung keinen absoluten Schutz mehr darstellt und kriegswichtige Ressourcen getroffen werden können, bevor sie das Schlachtfeld erreichen. Bueno dell'Oscio 1, alle 8 FPV-Drohnen gingen bei der Mission verloren. Doch hinter ihnen standen tausende weitere Drohnen, andere Aufklärungsnetzwerke und noch nicht aktivierte Pläne. Die Frage war nicht mehr, wie weit die Ukraine reichen konnte, sondern welche russische Nachschubroute als nächste gestoppt werden würde. Kiew Post. Issue 1. Was war Ihrer Meinung nach der eindrucksvollste Teil dieser Operation? Das Aufklärungsnetzwerk, die Überwindung der elektronischen Kampfführung oder die Präzision bei der Wahl des Angriffszeitpunkts? Teilen Sie Ihre Gedanken in den Kommentaren. Und wenn Sie hoffen, dass der Krieg bald endet, die Ukraine ihren Frieden wiedererlangt und die Menschen auf beiden Seiten keine weiteren Verluste erleiden müssen,